Ever get that feeling? Like when you look up at the night sky and just, I don't kind of feel this pull to figure out how it all got started.
It's a pretty universal feeling, I'd say. And today we're tapping into that. We're diving into some incredible theories about the universe, like from some of the biggest names in science.
Okay, set the stage for us. Who are these big thinkers, and what makes their ideas so mind-blowing?
Well, buckle up because we're about to drop into a 1988 conversation with Stephen Hawking, Carl Sagan, and Arthur C. Clarke. It's like getting a front row seat to the ultimate science roundtable.
Wow, talk about a power trio. And they weren't afraid to tackle the big questions, were they? Like the mother of all beginnings, the Big Bang. I've always pictured it as this massive explosion, but I've heard that's not quite right.
You're right, it's a common misconception. Hawking himself was really good at explaining this. He emphasized it wasn't an explosion in space, but rather the expansion of space itself.
So it's not like something blew up and threw stuff out into space.
Exactly. Imagine all the matter and energy of the entire universe squeezed into a space smaller, way smaller than an atom. That's where we start. Then, picture that tiny, unbelievably dense point suddenly inflating.
Hold on, so everything we see around us, galaxies, stars, even us, we were all once crammed into this infinitesimally small point.
That's the idea. And from that moment on, space itself began stretching, expanding in every direction. And get this, that expansion is still happening right now, billions of years later.
Wow, that's just wild. It's like, okay, terrible analogy coming, but imagine blowing up a balloon. The galaxies aren't just glued to the surface moving apart. The balloon itself, space itself, is actually getting bigger.
Perfect analogy. You've got it. The very fabric of space is what's stretching, pushing galaxies further and further apart. It's mind-boggling, but it's one of the cornerstones of modern cosmology.
Okay, I think I'm starting to grasp that, even if it makes my brain hurt a little. But if the universe is always expanding, does that mean it just keeps going forever? Like, is there an edge to it?
The million-dollar question. It all boils down to a sort of cosmic tug of war. See, we have this outward momentum from the Big Bang pushing everything apart, right?
Right.
But then you've got gravity, which is trying to pull everything back together. And the more stuff there is in the universe, the stronger gravity's pull.
So it's like a race between these two forces, expansion versus gravity, with the fate of the universe hanging in the balance.
You could say that, yeah. Now, if gravity were to somehow win this cosmic tug of war, well, that's where things get really wild.
Okay, I'm on the edge of my seat. What happens? Does everything just collapse?
Exactly. If gravity takes over, the universe could start contracting, everything rushing back together, getting hotter, denser. Eventually, it could all collapse back into that incredibly dense, incredibly hot state it started from, an event we call the Big Crunch.
A big crunch. It's like a cosmic do-over, a reset button for the entire universe.
But how do we know which way it's going to go? Are we headed for a big crunch or endless expansion? Honestly, we're still trying to figure that out. Scientists are looking for clues everywhere. How galaxies are moving, how matter is distributed throughout the universe. Even this faint afterglow of the Big Bang we call the cosmic microwave background radiation.
So it's like a giant cosmic detective story.
The biggest one there is. But this conversation wasn't just about beginnings and endings. Hawking, Sagan, and Clarke also dove into some seriously trippy ideas. Like this little concept Hawking called imaginary time.
Imaginary time. Okay, you're going to have to break that one down for me. What is that?
Get ready for a mind bender. So, we experience time as we know it, past, present, future, right? Hawking called this real time. But he proposed that there might be another dimension of time, one that exists at a right angle to it, that he called imaginary time.
Okay, hold up. Time at a right angle. I'm not sure I could even picture that. It's like describing a new color.
I know, it's a tough one to wrap your head around. Think of it this way. We typically visualize time as a straight line, right? But Hawking is suggesting time might also have a different shape, a geometry. Imagine the surface of a sphere. You can travel in any direction on that surface and never hit a wall. He proposed that the universe might be structured similarly in imaginary time, finite but boundless.
So not a straight line with a beginning and an end, but maybe more like a loop.
You got it. It's a revolutionary concept that really challenges how we think about reality. And things get even weirder when you start applying imaginary time to those cosmic enigmas we call black holes.
Black holes, yeah. Aren't those things like giant cosmic vacuum cleaners? What did our science trio have to say about them?
Well, for one thing, falling into one is definitely not on my bucket list, and Hawking seemed to agree.
I imagine it wouldn't be a very pleasant experience.
Not exactly a relaxing way to go. Hawking said the gravity inside a black hole would basically stretch you out like spaghetti, a process scientists call spaghettification.
Spaghettification. Catchy. But seriously, what would that even feel like?
Yeah, so Hawking described it as basically being ripped apart at the molecular level. Not quick or painless, more of a drawn-out stretching until you're thinner and thinner because of all those gravitational forces.
Okay, well, that's going straight on my list of ways I do not want to die. But didn't Hawking also suggest that black holes could be like doorways or something? I thought I remembered something about imaginary time being involved in that.
You're right, he did. While your trip through a black hole in real time would probably be a short one, things get a little more interesting with imaginary time. Hawking theorized that instead of disappearing completely, you might actually pop out of another black hole somewhere else in the universe.
So, black holes as cosmic shortcuts. That's kind of terrifying, but also kind of amazing when you think about it.
Yeah.
So where would we end up if we went through one?
That's the thing. According to Hawking, you wouldn't get a say in your destination. It would basically be random. Plus, there are a few logistical concerns.
Besides the whole spaghettification thing, right?
Yeah, besides that. There's also the intense radiation surrounding a black hole that would probably fry anything in its path, so a leisurely stroll through a black hole is highly unlikely.
Yeah, I'm thinking maybe not the best vacation plan.
Right. But here's the thing. Even if we can't physically travel through black holes, they're still incredibly valuable to us. They provide insights into the very nature of gravity, space, and time. Black holes challenge us to think beyond what we think we know.
So they're like these giant cosmic laboratories helping us unlock some of the universe's biggest secrets.
Exactly.
And speaking of mind-blowing concepts, we can't forget about Arthur C. Clarke and his fascination with something called the Mandelbrot set. I have to admit, I'm not familiar with that one. What is that exactly?
Okay, so imagine you're looking at a snowflake up close. You see those intricate repeating patterns, right?
I get it.
The Mandelbrot set is kind of similar, but on a scale that's almost impossible to grasp. It's actually generated by this incredibly simple mathematical equation, but it creates this infinitely complex and beautiful visual representation.
So we're talking about math that makes art.
Exactly. And what's really cool is that as you zoom in on the Mandelbrot set, you keep discovering these new patterns, these new details. It's like you could keep zooming in forever and you'd never run out of new things to find.
It's like those Russian nesting dolls. You open one and there's another one inside and another and so on. Does it ever end?
Well, that's a question that really interested both Clarke and Hawking. Does the universe itself work that way? Is it infinitely detailed? Like if we could just keep zooming in on smaller and smaller scales, would we always find new structures and patterns?
It makes you wonder if there's some fundamental limit to how small things can get, like maybe the universe does have a smallest possible thing.
That's exactly where Hawking's work on the fabric of the universe comes into play. He actually believed there might be such a limit, a sort of smallest pixel size for the universe, which he called the Planck length.
So you're saying there might be a point where we hit a wall where we can't zoom in any further because we've literally reached the universe's smallest building block.
That's what Hawking theorized, yeah. And if it's true, it means that even though the universe is incredibly vast and complex, it's not actually infinitely detailed. There is a limit to how much we can know, how deeply we can explore its mysteries.
Wow. It's kind of a lot to process. On one hand, it's like this incredible possibility of an endlessly detailed universe. But on the other hand, maybe there's a point where we bump up against the limits of what we can know.
It's a truly humbling thought.
It is. But even if we can't figure out all the universe's secrets, there's still the biggest question of all, right? The one we all want to know. Are we alone out here? It really is the ultimate question, isn't it? Are we just a tiny blip of life in some vast, indifferent universe? Or is there someone else out there staring up at the same stars, asking the same things we are?
I think it's a question that's been with us since we first looked up at the night sky, and for Hawking, Sagan, and Clarke, it was definitely a topic worth exploring. In fact, Hawking was surprisingly cautious about the prospect of actually encountering an alien civilization.
Really, I would have thought someone who spent their life trying to understand the universe would be all for meeting our galactic neighbors. Why the hesitation?
Well, Hawking knew his history, and he knew that encounters between vastly different civilizations, even here on Earth, don't always go so well. Think about, for example, when Europeans first landed in the Americas. It wasn't exactly the best example of peaceful coexistence.
That's a good point. Just because we might be eager to meet our cosmic counterparts doesn't mean it would be all sunshine and roses. What about Sagan and Clarke? Where did they stand on the whole alien encounter issue?
Well, as you might expect, Carl Sagan, the guy who championed the search for extraterrestrial intelligence, was a bit more optimistic. He dedicated his life to trying to find signs of life beyond Earth. He truly believed the universe was just too big, too full of possibilities for us to be alone.
And it does make you wonder, statistically speaking, with all those billions and billions of stars out there, how could we be the only planet where life decided to take root?
Precisely. And Clarke, being a science fiction writer, well, he took things a step further, proposing some really wild ideas. For example, he believed that if we did ever encounter an alien species, they would most likely be far more advanced than us.
Which makes sense when you think about it. The universe is billions of years old.
Mm-hmm.
If there are other civilizations out there, they've probably had a lot more time to evolve and develop, haven't they?
Exactly. Clarke even played around with the idea that maybe some super advanced civilizations figured out how to bypass the whole interstellar travel problem, perhaps even visiting Earth ages ago. Maybe some of those unexplained events in history, those things we just can't quite wrap our heads around, were actually evidence of their presence.
Okay, now you're venturing into ancient aliens territory. But I have to admit, it's a pretty cool thought to entertain. What if there's proof out there just waiting to be uncovered? But even with all this talk about the universe's vastness and the potential for life beyond our planet, it always seems to come back to us humans, trying to make sense of it all. For some, that search for meaning is tied to the idea of a higher power.
Absolutely. And our three science heavyweights, they didn't shy away from that either. They grappled with the age-old question, in a universe seemingly governed by scientific laws, is there room for God?
It's the classic science versus religion debate. But somehow, with these brilliant minds at the table, it felt less like a debate and more like a genuine exploration. So where did they land? What were their takes on the big God question?
Hawking, in his typical straightforward manner, believed that the more we understood about the universe, the less we needed to rely on the idea of a supernatural creator. If we could use physics to explain the universe's birth and evolution, then where does that leave a divine being? He even suggested that finding a complete and unified theory of everything, a theory that could explain it all, would be like knowing the mind of God.
So rather than a God who creates the universe from the outside, it's more like the universe arises from these fundamental laws of physics. And getting a handle on those laws brings us as close as we might ever get to understanding a higher power.
That's one way to look at it. And it's important to remember that Hawking's use of the word God was often more metaphorical. He wasn't necessarily talking about a deity in the traditional sense, but about the elegance and power of the laws that govern the cosmos.
It's definitely a more nuanced view, acknowledging just how awe-inspiring the universe is, while still basing our understanding in scientific principles.
Mm-hmm.
Did Sagan and Clarke share a similar view?
While they might have expressed it in their own unique ways, I think they both resonated with that idea. Sagan, for instance, often talked about the importance of humility and wonder when we're confronted with the vast unknown. For him, science wasn't about taking away the mystery. It was about appreciating the beauty and complexity of the universe even more.
It's about recognizing that even with every breakthrough discovery, there's always more to learn, more to explore.
Exactly. And Clarke, always the visionary, didn't see a conflict between science and spirituality. To him, they were simply different paths leading to the same profound truths about our existence.
It sounds like they were all on this quest for answers, driven by this insatiable curiosity about the universe and our place in it. And in a way, aren't we all?
They weren't afraid to ask those big, difficult questions, to dive headfirst into those profound mysteries that have captivated us since the dawn of humanity. And in doing that, I think they remind us that sometimes it's not about finding all the answers, but about the journey of discovery itself.
It's about embracing the unknown, those unanswered questions, and finding the wonder in it all. And on that note, I think we'll leave our listeners to ponder these big questions themselves. After all, this is just the start of the conversation.
Absolutely. The universe is a big place with plenty of mysteries still waiting to be uncovered. So keep looking up, keep asking those big questions, and who knows what you might find.